Hello, in this activity we're going to look at surface area for cylinders. This comes from the textbook Class Activity 13G, and it suggests taking a blank piece of paper, just 8.5 by 11 inches, roll it up, connect this in the system, and tape it without overlapping the paper so that this paper is turned into a cylinder. And it asks, what is the area of the surface of the cylinder? Go ahead and pause it and think about it yourself a second. Hopefully you're realizing that this distance here is the same as this distance here. Well, you're probably not even thinking about that. You're probably saying this surface has the same area as this, and so you're probably saying, hey, this is 8.5 by 11, so to find this surface area I could just take 8.5 times 11, and you're exactly right. 8.5 times 11 gives us 93.5. And the label, hopefully you're thinking area, you're thinking squares, you're thinking square inches. Now, I started jumping into this whole piece because that's where we're going next, is this idea of, if I have a cylinder, how is it related back to this rectangle? And we see that this distance here, this 8.5, is the same as this distance here. This has to be 8.5. So do you remember from before break, what is this distance around called? Hopefully you said circumference. And the circumference is found by taking 2 pi r, or 2 radiuses of diameter. So pi times the diameter also works there. So it then asks, actually, it's not going to go through this, but you can see if I had a different problem. In fact, maybe I will do that. Let's cut this out and go here. Let's say we didn't know, it didn't bring the cylinder in with it. There we go. Let's say this was a different problem, and let's just say it told us that this distance was 10. We'll call it millimeters. And it said, what's the surface area? Well, if you can imagine cutting this, it's still going to be a rectangle when I unfold it. But what's this distance? Well, if this is 10, then we know that that 10 is the diameter. And so we can figure out that circumference is pi times 10, which would be roughly 31.4. And then the problem would have to give us, this length. So let's say that was 35. I'm just making that up. It would be given in the problem. Then to find the actual surface area, if we cut it apart, turn it into a rectangle, it'd be 35 long by the circumference, which is 31.4. And then we could multiply that to get the surface area, and that would be in square millimeters. Now, notice that leaves off the bases, no circles. So what's the surface area of the cylinder if we want to include the base? Remember, we found this to be 93.5 square inches. To find the total surface area, we have to add in these two circles. And I guess we're going to have to use the circumference here, aren't we? So we know the circumference here is 8.5 inches. So we rolled it up. To find the area of the circle, what do we need? Remember my bad joke? Pi r squared, son. Pi r squared. Actually, the dad said pi r round. But how do we find the radius? We know the circumference. Well, we're going to have to do a little algebra. 8.5 equals 2 times pi times the radius. To get r by itself, we're going to have to divide both sides by 2 pi. And that tells us r is 8.5 divided by 2 pi. And that gives me r is 1.35 inches. And now we can find the area of the circle. Pi is 1.35 squared. And when I calculate that, we get 5.75. So my surface area is going to be 93.5 plus 2 times 5.75. Why did I take 2 times 5.75? Hopefully you said because we have 2 cylinders there. Times 2 plus 93.5. Final answer then is about 105 square inches. So, key ideas, surface area for cylinders is to remember if I cut a cylinder and unwrap that, I would end up with a rectangle. And if I was looking to find the circle area as well, I would have 2 circles to include in that. Now, you may be wondering, when do I include the circles, when do I don't? It just depends on the problem and what it's showing. Here it says not including the bases. Here it says include.